with displacement current. So now let us take another topic now to show or to explain the concept of conduction current is equal to displacement current. You might be asked a question like, prove that the conduction current IC is equal to displacement current ID. So this might be one good question, very important. So you need to prove conduction current is equal to what? The displacement current. So as I've already told you, if you have a charge capacitor like this, so this is a charge capacitor, plates. Okay, and here you have assume a current is flowing inside this circuit, or just say if you have a varying magnetic field, if you have a closed loop and if you have a varying magnetic field B here, so what happens, there will be an induced EMF or there will be a current inside this circuit. So magnetic field varying sinusoidally with time is applied within the loop to produce an EMF about the closed path, and this EMF is given by EMF is equal to V is equal to some constant V naught cos omega t. So this is the equation for EMF, which is with respect to a time varying sinusoidal EMF which is produced due to this varying magnetic field. So V is equal to V naught cos omega t. This is just an assumption here, where I have produced this much amount of EMF due to the varying magnetic field in this closed loop. Okay, so using circuit theory concept in this loop, so what is I is equal to, what is current, what is I is equal to, can I call this as I is equal to C dV by dt? I is equal to C dV by dt. Can I say I is equal to dq by dt, dq by dt, but q is equal to what? Q is equal to CV. Therefore, I is equal to C is constant dV by dt. So whenever you have excited this closed loop by a varying magnetic field, that induces an EMF inside this due to the charges which are at motion now. The charges are at motion. So these charges becomes, it will gain some speed or it will gain some movement, displacement of this charge, and that produces a current. So this current I can relate it to this charges which are tend to move due to this magnetic field. So I is equal to C dV by dt, but what is this V is equal to? V is equal to V naught cos omega t. So I'll substitute that value here. So I will become I is equal to C d by dt of V naught cos omega t. V naught cos omega t. Call this as equation 2. Okay. So now we know the equation for capacitance. So C is given by C is equal to epsilon S divided by D. C is equal to epsilon A divided by D. So this term you know. What is epsilon? Epsilon is permittivity of dielectric. This is permittivity of the dielectric shear between the capacitor plates, and S is area of each plates. So S is area of each plates, and D, what is D? D is separation or distance between the plates. So we know that capacitance can be given as C is equal to epsilon S into D. I'll call this as equation 3. Now substitute equation 3 into equation 3 in 2. Therefore, I get I is equal to epsilon S by D into V naught. So what happens to d by dt cos omega t? So differentiate cos omega t with respect to t. I'll get minus sine omega t into omega. So finally I can write I is equal to minus omega epsilon S by d V naught sine omega t. Call this as equation 4. I'm just trying to get the conduction current. So this is a conduction current. So I can call this as IC, or the total current here. This is one part. So now let's just try to concentrate with respect to the capacitor or a displacement current now. So now we did calculation for this part I. Now we will do the calculation for this ID, that is displacement current ID. And we know the displacement current ID equation, right? So we'll start from there. And then we have to prove this I and this ID are same. Then let us go to the second half of your derivation or proof. So as the capacitor charges and discharges continuously, charge transfer takes place from one plate to another plate. So there will be a positive cycle, so it will be a charging, and then again in negative cycle it will be discharging. So in both the cases, at both the points, charge transfer takes place from one plate to another plate in opposite half cycles. Hence the displacement current flows in the capacitor. So due to this, there will be a displacement current flowing in the capacitor, and it is given by ID is equal to S dou d by dou t. So how did I get this equation? So there is a small derivation that you need to remember. So I know what is displacement current density. Displacement current density JD is equal to dou d by dou t. But what is JD is equal to? JD is equal to ID, total current over total surface area. Okay. So I started with this. What is current density is equal to? JD is equal to displacement current density is equal to rate of change of displacement of electric flux density between the charge plates. So JD is equal to total current over total surface area. So this is equal to, so this implies ID is equal to S dou d by dou t. Okay, so now I'll write it here. ID is equal to S dou d by dou t. But we know that D is equal to epsilon naught times E. Why epsilon naught? Why? Because okay, we shall consider epsilon only. Let me keep it epsilon because I have not said air as a dielectric medium. So I'll keep it can be anything, any dielectric medium. So epsilon E, substitute the above equation. So ID will be equal to S epsilon dou E by dou T. But what is E is equal to? Electric field E is equal to with respect to that capacitor. So you could see E is equal to V by D. How? What is work is equal to? Work done is equal to force into distance. Work done is equal to force into displacement. So the displacement is scalar quantity. Force into displacement. But what is force is equal to? Force is equal to QE into T. Therefore, E is equal to W by Q into 1 over D. But what is W by Q? Work done per unit charge. It is potential. So it is V by D. I'm just trying to represent this electric field in terms of potential and the displacement. Sorry, distance between the capacitor. Since E is equal to V by D, therefore ID will be equal to S epsilon by T dou V by dou T. But what is V is equal to? V is equal to V naught cos omega T. V is equal to V naught cos omega T. Therefore, ID is equal to minus omega epsilon S by D V naught sine omega T. So if you substitute this equation here and then take the partial derivative with respect to T, you will obtain ID is equal to minus omega epsilon S by D V naught sine omega T. Call this as equation 5. Compare equation 4 and 5. See here, this is my equation 4 and this is equation 5. So if you compare this equations 4 and 5, you can say the displacement current is equal to equation 4 is equal to equation 5. Therefore, conduction current is equal to displacement current. What if hello, am I audible?
Yes,
Sir,
sir.
Okay, so I hope you've uh, got this derivation in the sense like proof for conduction current is equal to displacement current. So in this class, we have derived the equation for modified circuital law, which happens to be one of the Maxwell's four equation, one, and we also proved that conduction current is equal to the displacement current. Displacement current happens to be the current inside the capacitor. Conduction current is the current in the loop, and we have also proved that conduction current is equal to the displacement current. So these two concepts are very important. So make sure you study this concept, both the concepts. Like you can definitely expect at least one question out of these two questions or two concepts. So if you have any doubts, just let me know. Yes, I'm done with this session for today's session.